Hello, this is Jessica Dunn, and we are going to work through the problems for Chapter 8. So for the first problem, we're looking at beta and the capital asset pricing model. We're looking at an investment. This investment has a beta of 1.5. The risk-free rate of return is 7%. The return on the market portfolio of assets is 10%. And we believe that this asset will return 11% per year. So you are told to skip Part A, but Part B asks, using the capital asset pricing model, find the required return on this asset. So remember, the required return on an asset is equal to the risk-free rate plus beta times the market return minus the risk-free rate. And together, the market return less the risk-free rate is referred to as the market risk premium. The risk-free rate of return in this problem is 7%. We have a beta of 1.5. The market return is 10%. And the risk-free rate of return is 7%. So we can calculate the required return on this asset. So 1.5 times 3%. Oh, that didn't work. Times 0.03 equals, and then we add to that the risk-free rate of return of 7% to give us 11.5%. This asset has a required return of 11.5%. So would we recommend this investment? We expect this asset to only return 11%, but because of its level of risk, because of the level of beta, it should return 11.5%. So no, we would not recommend this asset. That's because expected return of 11% is less than the required return of 11.5%. And Part D, what if the return of the market return drops 1%? So now it's 9% instead of 10%. What is the new required return on this asset? So the new market return is 9%. So we can use our capital asset pricing model. We know the risk-free rate of return is 7%. Our beta has stayed the same. The market return has changed to 9%. And the risk-free rate is still 7%. We can put this into our calculator. 1.5 times 2% plus 7%. So the new required return on this asset is 10%. So now if we looked at C again, would we recommend this asset? And the answer would be yes. We would recommend this asset because it has an expected return that is greater than or equal to the required return. So number 2. Number 2 asks you to calculate the required rate of return for an asset with a beta of 1.8. The risk-free rate of return is 5% and the market return is 10%. So we use the capital asset pricing model. So the required return on an asset is equal to the risk-free rate plus beta times the market risk premium, the market return minus the risk-free rate. So we know all of these components. We're wanting to calculate the required return. The risk-free rate is 5%. Beta is 1.8. The market return is 10%. And the risk-free rate is 5%. So we can calculate the required return on this asset. We simply plug it into our calculator. So we have our 1.8 times 5%. 10% minus 5% is 5%, plus the risk-free rate of 5%. And that gives us a required return of 14%. If investors become more risk-averse and the market return rises to 13%, what happens to the required rate of return? So part B, the required rate of return, the risk-free rate has not changed. Beta has not changed. The only thing that's changed is the market return. So we can plug this into our calculator. We have 1.8 times 8% plus 5%. So our new required return is 19.4%. And we know that and you were also told that you didn't have to do part C. So number 3, Sharon Smith is a financial manager for Barnett Corporation. She's looking at 3 separate investments, X, Y, and Z, and she will evaluate each of these to decide which is the better. Her company already has in place an expected return of 12% and a standard deviation of 6%. The expected returns and standard deviations of the investments are in this table. If Sharon were risk neutral, which investment would she prefer? If she were risk neutral, that means that she wants the highest return regardless of the level of risk. So she would prefer assets X and Y. She would prefer asset X because it has the highest return and it's still greater than the 12% required return her company has. And asset Y also performs at least as well as her company's expected return of 12%. If she were risk averse, that means that she would pick the asset with the lowest risk regardless of its level of return. So if she were risk averse, that means that she wants the highest level of return for a given level of risk. Because she wants to maximize the return-risk relationship. So she wants the highest level of return that she can with the lowest level of risk possible. So looking at these investments, we see that asset X has the highest return, and it also has the lowest level of risk as measured by the standard deviation. So she would choose asset X. If Sharon were risk-seeking, that means that she would choose the asset with the highest level of risk regardless of the level of return. And so she would choose asset Z. Asset Z has a standard deviation of 9%. Most people are risk averse, meaning that they want to be compensated for the level of risk that they're taking. So an increase in risk means an increase in return. They want to maximize the amount of return that they can get for a given level of risk. So most financial managers are risk averse, so they would choose asset X. It has the highest expected return and the lowest standard deviation. And number 4. Here we're going to look at the normal probability distribution. We are assuming that returns are normally distributed, and the expected return is 18.9%. The coefficient of variation is 0.75. So we need to find the standard deviation of returns. So we know that the coefficient of variation is equal to the standard deviation divided by the expected return. So we know 2 of these 3 components, and we can solve for the third. The coefficient of variation is 0.75, and the expected return is 18.9%. So what is the standard deviation? You simply multiply both sides by 18.9%. So standard deviation is equal to 0.75 times 18.9%. And that gives you 14.2%. So part B asks to calculate the range of expected returns for different probabilities of occurrence. So first we're looking at calculate the range if we want to be 68% certain that our answer is correct. So part B. 68% of outcomes lie within 1 standard deviation of the expected return. So we have 18.9% minus our standard deviation of 14.2% and 18.9% plus our standard deviation of 14.2%. So 68% of our observations will lie between 4.7% and 33.1%. If we want to be 95% confident in our answers, then we know that 95% of observations lie within 2 standard deviations of our expected return. So we have 0.189, our expected return, minus 2 times the standard deviation of 14.2%. Then we have our expected return of 18.9% plus 2 times the standard deviation of 14.2%. So 95% of observations will lie between negative 9.5% and a positive 47.3%. And finally, 99% of observations lie within 3 standard deviations of our expected return. So we have our expected return of 18.9% minus 3 times the standard deviation of 14.2%, and our expected return plus 3 times our standard deviation of 14.2%. So 99% of observations will lie between a negative 0.23 and a positive 61.9%. 0.4%. So if we wanted to look at this probability distribution graphically, we know what the normal distribution looks like. So it's peaked in the middle with the short tails. They continue on forever. They keep getting smaller and smaller. We know that this normal distribution is centered around the expected value. Our expected return is 18.9%. We know that 68% of values lie within 1 standard deviation of the mean, which we calculated. So we have 0.047 and 0.331. We can continue this out. So we have 95% of observations lie within 2 standard deviations of the mean. So negative 0.09 and 0.47. And finally, 99% of observations are going to lie within 3 standard deviations of the mean. So negative 0.24 and a 0.61. These are all of the values that we just calculated.